Yeah, thank you for having me. So as Tiona mentioned, I'm going to be talking about the future of autonomous weapons. So I want to start out with a recent example. So there was a United Nations report that came out last year, noting that Cargo 2 drone was used to, quote, hunt down and remotely engage soldiers in Libya. Now, drones have, of course, been used in combat for a long time, but what makes this significant is that the manufacturer, STM, noted that this system is particularly capable of using artificial intelligence to identify targets and engage them automatically. Now, one complexity here is that it also noted that it's an option. You don't necessarily have to do it. So, after this UN report came out and the story ended up going viral all over the world, STM ended up being very clear that they don't actually typically use it in this way. But interestingly, the Turkish government came out and noted that even though, yes, they did not use the Cargo 2 drone in this way, they do have the ability to field that capability. That is using machine vision, using artificial intelligence to recognize targets and then selectively engage them. That is, okay, I see this as a tank. Within my rules of engagement, I can attack a tank, therefore blow that up or whatever the particular target is. So the point being here is the notion that we're using artificial intelligence to automatically engage um, folks on the ground and potentially kill is here, and that's here now. Now, what we can expect to see over the next coming decades is see more use of these weapons, using autonomous weapons generally, as well as artificial intelligence in combat across more domains, more platforms, and all sorts of more different ways. That said, what this actually means is going to be somewhat mixed. You're going to have a mixture of both benign enhancements, that improve that militaries like to make their ability to conduct war more efficient, and that humanitarians like as well, because arguably, sort of Usman mentioned, there may be improvements sort of accuracy that ultimately is actually good for protecting civilian lives and controlling war. At the same time, there are some very real concerns about where this technology is going, particularly around creating new potential weapons of mass destruction, akin to chemical, biological, radiological, even low level nuclear weapons. And what does this mean for nuclear war? Because autonomy may not necessarily be restricted to conventional battlefields. What happens if states, or not if, but when states start integrating artificial intelligence autonomy with their nuclear weapons complex? And what happens if a artificial intelligence makes decisions around launching nuclear weapons, not just conventional? Let's see, next slide. So I think what this future looks like is going to be pretty dependent on three sort of big questions that I think, you know, I and other folks can sort of provide and suggestions and thoughts on, but I think ultimately it's going to depend on a variety of factors. So one of the biggest ones I think is how fast and how far do these weapons proliferate? That is, do they quickly spread across the globe, or is it even to like say non-state terrorist actors, or is it something that tends to be more restricted to um, states? And likely, there's going to be some bare level of variation within that, where, if you have a, say, artificial intelligent, like advanced fighter jet, that's probably something that's going to be more restricted to your more powerful states, and not something a terrorist is going to start building in their garage. But conversely, if we talk about, say, an autonomous gun turret, simply say equipping machine vision with like a machine gun or a sniper rifle or something like that. There's basically already instructions online on how to do that. I'm not aware that terrorists have actually used that, but theoretically, all they really need to do is just decide to do so. And but whether they do or not is, of course, an open question. Likewise, how reliable do some of these machine vision systems become? And I'll get into this a little bit more as I go on. But one of the big challenges we're seeing is that some of these systems, artificial intelligence systems, are quite brittle, particularly around recognizing what objects are. So, how effective does this actually become? Because if it turns out, well, it's really not that good, then probably states aren't going to use it that much. But it's going to depend a little bit on sort of how good and what situations, because states may be varying in their willingness to sort of accept a risk of error around these systems. And then, sort of conversely related, but somewhat different, is how effective do these systems actually prove in combat? We've seen from sort of the history of autonomous weapons that generally they've been using sort of more defensive purposes, providing last minute support against incoming missiles or planes or that sort of thing. But when we start talking about sort of more offensive roles, going into cities, targeting tanks on their own, targeting infantry fighting vehicles, targeting all sorts of whatever, it's a little bit unclear. And especially what happens if when these systems start going up against other types of defenses. What happens if you have a whole bunch of drones versus a air defense unit? In theory, that might be very effective in taking out some very advanced, sophisticated air defense units. But the reality is, we don't really know because we've only seen few examples, and the best we can do is sort of modeling and simulation, which are ultimately guesses based on various assumption parameters. So, how effective do these actually systems prove? Now, to give you a sense of where I'm going to be going here, I'm just going to do a brief set of foundation. I'm going to expand a little bit on where I understand the situation, where are we now. I'm going to look at some of the sort of broader future trends. I'm going to look at like, what does this mean in practice? Look at what does it kind of a robotic battlefield look like? And I'm going to note here some of the more positive, at least from a military and humanitarian perspective, and then sort of the larger concerns. And then hit, okay, well, what do we do now? So to start, set a foundation here, like the notion of an autonomous weapon itself has been around for 150 plus years. Arguably, the first autonomous weapons go back to landmines, which were first used, I believe, in the American Civil War. These aren't anything particularly sophisticated. All you're really talking about is a simple like pressure sensor to say, all right, this isn't a leaf, this is a human, or this is a tank, or like, I don't know, not a tank at that particular time period, but this is, something of concern here that of sufficient weight that I want to attack it. So it just blows up. And notably, even though autonomous weapons have been around for 150 years, some of these debates have also been around for 150 years. I mean, during this Civil War, when landmines were first used, many of the folks who were, I can't remember if it was the Union or the Confederacy, but either way, there was basically some pretty significant opposition. Folks believed that, this wasn't the appropriate way to do war. That it should be a human making a decision here, as opposed to just sort of leaving a bomb and sort of dealing with it. And I think one of the important things there is to note that like the autonomy itself is not necessarily really all that sophisticated. I mean, when we're talking about autonomy, all we really mean is the ability of machines or any sort of non-human entity, I suppose, to make decisions about who and when to kill. And that doesn't necessarily need to be at all sophisticated. You can imagine, say, setting up a basic system where you sort of like tie a rock on a rope, for example, and when the rock falls, it just hits a fire button, and you've got to shred the rope a little bit, so it takes a little bit amount of time. That's hardly anything sophisticated. It just means you're just basically have a time sensor there. But it's not any, but it's still making a decision by itself to sort of attack based on some sort of preset parameters there. It's not sophisticated, and probably no military would ever want to use that. But the point is, it doesn't necessarily need to be complicated. Likewise, we've seen some of these broader trends in autonomy generally with applying that type of basic autonomy in many different areas for many years. I mean, when we're talking about time, we're just talking about the ability of machines to control things. Simple like autopilots that have happened since, I think, some of the earliest autopilots in the 1950s, 1960s to sort of fly planes. That's a form of autonomy, and that the plane is operating by itself in relatively simple ways. But what we're increasingly seeing, and I think where much of the concern is in practice, is around the development and incorporation of artificial intelligence. And particularly, at least at the moment, what we've seen is greater increasing use of machine vision systems. That is, artificial intelligence that are designed to recognize and classify particular objects, whether that's, as a tank, whether it's a person, whether that's, a particular type of tank, particular type of infantry fighting wheel, particular type of plane, whatever. And so we're seeing that increasingly incorporated in a variety of systems. And I don't believe that's all that new, even though in the Cargo 2 incident, what was new there is that we're sort of making the use to kill. I believe target recognition systems of this type have been used for a number of years. But it's typically used sort of as a decision aid for militaries to be like, okay, that look, the machine thinks that that's most likely a tank, so I suppose, and I agree, that kind of looks like a tank to me, so we'll blow that up. Now, one of the challenges, though, is that current artificial intelligence tend to be great at really narrow, defined tasks. So at the bottom left here, you see a picture from a recent event where a artificial intelligence AlphaGo beat the world's leading grandmaster or best player in Go, a much more complex game than chess. But what's notable here is that Go is itself a relatively constrained problem, and that Go has, like any game really, has narrow defined rules about what are the particular types of things you can put on the board, what are the particular types of movements and plays. You have specific rules for adjudication. If you put your piece there, then you'll flip over the other person's tiles, that type of thing. You're also in a very constrained space, right? You have a board is only so far, so big and so wide, and conversely, everyone has a very clear view about what's actually going on. So one of the ways the systems in this particular case learned is by being fed large numbers of examples of Go games over the past, however long period they have had records for, and basically over using all of this data started making conclusions about, okay, this type of approach tends to work better, this type of approach does not, that type of thing. The problem, though, is that when you shift to more military tasks, actually, before I jump there, the problem is that this is relatively narrow, and the challenge is that, like, because the system has learned from all of these different examples. What happens if you say change the rules of Go? You expand the board, you shrink it, you allow different types of pieces instead of having to say just black and white. What if you add variations within the white pieces or within the black pieces? Or what happens if you add green pieces or red pieces or that type of thing? That artificial intelligence that was able to beat the greatest masters in all of the world are now basically useless because it's been trained on something entirely useless. Now, you could, of course, then retrain using new data, using new rules, but that original system is not going to work very well. And that's going to be a particular problem when it comes to a lot of military tasks, because if we're talking about militaries, we're not talking about very clear views. In fact, adversaries in a military conflict are going to try to obstruct that, try to make it harder to understand where their units are, from using camouflage, using decoys, using other types of disguises, feeding disinformation to an adversary. Likewise, units are going to move on and off the battlefield. Your tanks are going to roll to some other particular area. They're going to move in and out. You may have surprise attacks where someone didn't realize, oh, there's an air defense system in this particular area. And so the ability to adapt is going to be really difficult. That said, certainly you are going to have, in some limited cases, those same sort of narrow defined tasks. So I think one of the interesting examples, recently, a Defense Advanced Research Projects Agency at Department of Defense of the United States, which is basically a high-end art research and development arm of the U.S. military, conducted a simulated fight between an F-16 and an artificial intelligence, in which the artificial intelligence basically dominated the F-16, and it was using with a real pilot. And in part, that's because I think a dogfight is a more constrained task there. You have particular rules engagement. It's you can kind of see the other plane as you're going along. Yeah, maybe there'll be cloud cover and that sort of thing, but more or less you can kind of see what's going on. And a lot of the dynamics are very technical and calculated, getting the actual movement geography right as you're flying above or below the particular plane or your adversary plane and moving around it. And conversely, there's a significant room for error there if your pilot miscalculates or, doesn't anticipate right, or equally importantly, doesn't go as quickly as the artificial intelligence sort of making a decision. So in a situation like that, artificial intelligence may actually be fairly effective. But again, that's a little bit more down the road. So when it comes to the future, though, I think what we can expect to see is sort of more use of unmanned systems, which aren't necessarily autonomous or using artificial intelligence, but certainly have incentives to do so. We have states across the globe who are developing unmanned surface vehicles, unmanned ground vehicles, so undersea vehicles, numerous forms of unmanned aerial vehicles, from simple quadcopters, as you see in the top right, to much larger, combat vehicles like the MQ-9 Predator and that type of drone system. We see that now in the combat in Ukraine with the use of the Turkish Bayraktar TB2. Now, even though unmanned systems are not necessarily artificially intelligent and autonomous, I think it creates significant incentives to do so and makes it easier to do so. That is, if you have the pilot in there, what do you need the autonomous systems for? Because the pilot is there to do everything. But if your pilot is, sitting way far away, and may not necessarily be as accessible and maybe slightly more wearied out, and you may be able to remove the pilot temporarily from the situation. There's a bit more incentive to use AI and autonomy, and we can see that in some of these systems. So, like the Bayraktar TB2 has various forms of autonomy in which it can sort of take off and land by itself. Other types of systems may, for example, be able to, I don't know, recognize what airstrip you're at, and then be able to specifically plan and set GPS coordinates for landing, that type of thing. And we can expect to see that greater AI and autonomy in more diverse military functions. Because it's important to remember that when we're talking about autonomy, again, we're talking about the ability of machines to do things on their own, which can include any type of task. It doesn't necessarily mean simply shooting. It may include sort of movement decisions, like, okay, how do I move within that dogfight? It may be, which may include, say, as we see in the bottom left, like, say, spreading out across the sea, collecting sensor information to look for like adversary submarines and that type of thing. And so I think we can expect to see that and across many different types of elements, to include, shooting and directly engaging targets. I think we'll also see these systems increasingly work together in potentially developing in large autonomous swarms. So the U.S. military, for example, naval postgraduate schools, again, what happens is we have swarms of up to 1 million different drones operating across across the surface, across the under the sea, across the air. It's very theoretical work at the moment, but we can expect to see more of that. And we're already starting to see that in the battlefield, as just last year, Israel used for the first time an actual drone swarm, meaning that there was communication and cooperation between the drones, and it used that in the fight against Gaza, in Gaza. Now, those systems weren't using artificial intelligence, to my knowledge, to select and engage targets, but theoretically, you can imagine that being a thing. So when it comes to what that actually means for the battlefield, though, I think the great value for militaries is that they see more rapid decision making, sort of the phrase that gets tossed around, sort of making decisions at machine speed. I don't particularly like that phrase for a variety of reasons, but basically the gist is more rapid decision making on the battlefield. You also have potentially sort of cheaper systems and reduced training requirements. So to go back to the example of sort of like fighter pilots and autonomous like drones. So, if I have if my drone system or my aircraft can automatically just land and taxi and put itself basically in the hangar, then I don't really need to train a pilot to actually do any of that. Now, maybe I want them to be aware of that, but I don't necessarily need to do anything about that, which means I can make more pilots more quickly. Conversely, when we're talking about autonomy and AI, one of the big advantages that militaries see is sort of removing the human from some of those systems. So if we talk about planes and drones, the big advantage there is you don't really need to support the pilot, which means you have less material. You don't need to worry about all the types of things that keep like human beings alive, from oxygen to water to whatever else they need, which means you can sort of constrain and make simpler, cheaper system. So for militaries, that's really great value, because it also means you can field more of them. Now, of course, there's a question there about how effective those systems are in practice. What happens when your big advanced drone comes up against a air superiority fighter, against a more advanced military? That's something that, at least in the United States, and I think just generally, has not really happened since really the Cold War, and probably since the Korean War, arguably. And technology has obviously changed massively since the 1950s. So what does that look like? We don't simply know. In theory, there are some significant advantages, but there's an open question about how significant that is, which in turn has a significant reflection of how extensively these systems are used. Conversely, there's also potentially some good humanitarian benefits around more precise targeting to reduce risk of accidental casualties. I'll keep this a little bit short because I think Usman, it sounded like, hit this fairly well. I'll just simply note there was a recent example of this, an Israeli assassination of an Iranian scientist recently, in which basically the Israelis used an AI enhanced, I believe it was like a sniper rifle, remotely operated, in which basically the system was able to take out a Iranian scientist without hitting his wife, who is something like barely like inches away in the particular car. What the example showed is like the way in which these systems can be very precisely targeted to hit folks, which suggests that there may be actually reduced risks of accidental casualties, which could be a good thing. And of course, as we mentioned, robots don't necessarily feel that sort of hope for your tiredness, but there is a question about how quickly that sort of advantage manifests and to what extent sort of that trades off with some of those narrow limitations. Like, okay, they don't feel hope or fear, but if they're still making errors because they can't recognize that like that's a tank versus a dog, that becomes a little bit of a challenge. Likewise, and that sort of last point bleeds into, I think you get fears of relatively new destruction. I'm probably going to go a little bit quickly through this. I see I'm running up on time here. But one of the issues we see is that getting back to that earlier point of the narrowness of AI is that some of the machine vision could actually be quite bad because often these systems, the artificial intelligence is quite brittle. So as you see on the right-hand side, this is my favorite example of this. This is done by OpenAI, one of the leading artificial intelligence companies, to show some of the brittleness and potential weaknesses. So on the left, this is the same artificial intelligence system. It classified this apple as a Granny Smith apple with 85.6% accuracy. That seems like reasonable. That seems like that system's working pretty well. But when they stuck a little sticker on there that says iPod, it actually shifted extensively. Instead, it concluded with, and I'm blocking here, but like 99.7% accuracy, that's an iPod. Now, any human being with a half-thinking brain would say, no, that's not an iPod. That's an Apple with a sticker on it. But a machine doesn't necessarily recognize that. And you can imagine in the battlefield, that can create some pretty significant challenges. You know, what happens if a tank, enemy tank puts a sticker on there that says school bus? Does it then classify it as a school bus and it's now not working very effectively? And that's a problem because you can create new risks to civilians from potential targeting errors. It may also mean failed military operations if you misrecognize a target and blow up the wrong thing. And I think equal and especially concerning is potential for accidental escalation. That is, not only what happens if it hits a civilian or the wrong military target or the wrong target in general, what happens if it hits a third party, like a military that's not involved, either their civilians. You may potentially bring in new combatants, or alternatively, you may be in a situation where rules of engagement are relatively narrow and it may accidentally blow something up and escalate a conflict that was wanting to be relatively small and narrow. And now you have a larger protracted conflict. Now, there are debates about how significant that is. And to some degree, I'm skeptical, but I think that is definitely a real worry and something that needs to be discussed. Likewise, I think what happens when you start combining autonomous systems in larger masses, when you start getting those thousands of drones, I think, in my view, that creates a new potential weapon of mass destruction because you're combining these risks of error at massive scale. If we're talking about autonomous gun turret, yeah, you have that risk of error and that might happen. But if you're talking about 1,000 drones, you have 1,000 points of where you have these potential failures. And if you're talking about a drone swarm, we have communication between them. An error in one may create error in all of them, or a small or larger, but still relatively small subset. So you're now looking at potentially much greater risks of harm. And I should say again, states are looking at these systems. India, for example, I think it was last year or the year before, showed off what they described as a swarm of 75 drones that operated together to take out various targets. And the commentator noted that they're working on developing 1,000 drones operating autonomously. Likewise, what happens if drone autonomous weapons are combined with CBRN, chemical, biological, radiological, and nuclear weapons? That could be a big challenge because one of the rationales for getting rid of chemical and biological agents was that they aren't all that accurate. So militaries were willing to give these systems up because they believe they're really not all that reliable. But if you have artificial intelligence and autonomy improving that sort of direct accuracy, then that's potentially a pretty significant rationale for removing some of those norms. Likewise, if we start moving into the nuclear delivery, currently under the Nuclear Non-Proliferation Treaty, states are not required to have human control over the decision to make nuclear weapons. So, what if a state decides to make an autonomous nuclear weapon? Then you're looking at the risks of error, mean risks of creating accidental global nuclear war, and potentially escalating to massive catastrophic harm, and depending on how things play out, potentially an existential risk to all of humanity. Now, whether states choose to do that or not is, of course, a different question entirely. But at least at the moment, there's nothing in international law that does so. And there have been some calls to incorporate artificial intelligence and autonomy in nuclear weapons. And there's some reports, for example, around Russian system, dead hand systems that automatically designate lower level decision making to folks in the field. And that's not exactly the same as like a fire order, but it shows a willingness to sort of automate some elements of nuclear command and control. So what does this leave us? And I'll keep these relatively quick here, just given the time. I think there's a broader question for society. Under what circumstances should machines be allowed to kill, given these challenges of machine vision? And obviously, there are going to be some differences here around whether it's appropriate, say, target tanks versus people, or target only in defensive means. Militaries need to be thinking about how can and should autonomy and AI be applied in the battlefield. What are the ways that are more or less effective? If you're using artificial intelligence, how do you ensure that's done safely and responsibly? If you are going to use that machine vision, how do you make sure it's reliable? You're going to need test and evaluation. You're going to need just generally simulations to make sure it's working. And more generally for the global governments, what are those appropriate restrictions on autonomous weapons and AI? Personally, I'm skeptical about the notion of a broad ban. I don't think that's going to work. Regardless of the sort of the moral arguments, I think there are too many practical military ones, but there may be opportunity for more restricted things, such as incorporating bans within the Nuclear Non-Proliferation Treaty, for example, or having more limited bans on massive drone swarms, that type of thing. And likewise, sort of similarly, but not exactly the same, is what do you do about autonomous weapon proliferation? To what extent is it even possible? Because if the issue is a matter of code, is it even possible to restrict these weapons? Yeah. So ultimately, I'll conclude by saying, the future of autonomy and AI is well likely to see more systems used in more ways, and I think there are some good things for both militaries and humanitarians. There are also some very real concerns when it comes to massive drone swarms combining weapons with chemical, biological, radiological, nuclear weapons, and of course those risks of error from machine vision. So what happens next is ultimately up to all of us. Thank you.